Hello, and welcome to One Configuration, Many Imports, presented today by Florent Bayville, Emre Hizal, and Eric Nord. Over to you.
Hey, thanks. And yeah, welcome to our session. Today, me and my teammates will be talking about a library called Import-spec, which provides a uniform configuration facade for tools running imports to Neo4j. And so, who we are? Yeah, we are the connectors team. And what we do is making your lives easier if you want to import or export data from or to Neo4j. And yeah, we are here as three of us today. We'll be giving you this session. So the plan for today, myself, will be talking about how importing data today looks by showing you different runtime environments with the same data set with different configurations. And then Eric will explain to us how Import-spec comes to the rescue and give us some insights about it. And after that, Florent will give us a demo where he will be showing us Import-spec in action with different runtime environments. And at the end, it's back to Eric. He will wrap up and close the session. So importing data today. Let's dive how it looks. So I'm gonna give you an example here, and yeah, let's say you want to import a CSV data looking like in the example, and so we can say intuitively we can say we will have a person node, and we will have a book node, and then there will be a reads relationship between them. And yeah, let's see the examples with this. And so with this data set today, this is how it looks with Neo4j admin database import. And by the way, speaking of Neo4j admin, it's a tool used for bulk importing large data sets from CSV and Parquet files into a new Neo4j database. And yeah, if we look closer to this command, Neo4j command, and you will see that we will have to statically create the header files for each node and each relationship. And yeah, with property definitions. And yeah, this is the Neo4j admin example with the dataset that I showed you. And then we have Cypher's load CSV with the same dataset, same example. It's pretty much the same, but just how we define it is just the Cypher way. So, so as you can see here, we define each node and the relationship them, but it's basically the Cypher way. And also, just speaking of load CSV, we use this call in transactions here, which batches imports on the server side to prevent memory out of memory errors. So another example will be Spark. This is how we define it with Spark. You can see the same nodes, same relationship with same properties. So as you can see, the list goes on. We have seen three examples: Neo4j admin, Spark, Cypher's load CSV, and we could also use Aura Console's import, Kafka, BI connector, JDBC, and APOC, and so on. And yeah, to summarize what we talked so far, each import method comes with its own trade-offs, different learning curves, and different configuration surfaces. And yeah, before import-spec tool, these might be a bit, imports might be a bit complex and inconsistent, but yeah, this is where import-spec comes to the rescue. So I'm handing it over to Eric.
Yeah, as you can see, there's so many different ways to import data to Neo4j, and it's a headache to keep track of it. So this is why we felt like we needed something like Import-spec. We figured, why can't we just have one single unified configuration surface for these imports? Because essentially we're doing the same 3 steps. We're initiating a database with a schema. We're moving data into the database by mapping them to nodes and relationships. So to understand what Import-spec is, obviously it's a spec, and we said it's a uniform configuration spec. That's not all of it. That's just what carries it. So what we also see is that Import-spec comes with an extensible JVM library, which you can programmatically interact with. This allows you to define your custom, like readable data sources. You want to read from CSV, Parquet, zip files if you're creative. It comes with runtime integrations, and you can define your own validation and target extensions. This also means that it's all declarative, so it's import runtime agnostic. This means that you can define your spec and really decide later if you want to do the actual import via Spark, JDBC, Neo4j admin, have you not? And it's actually also Neo4j deployment agnostic. When you're writing the spec, you don't need to define if you're going to do it in Aura, you're going to do it to a self-managed one, or even an embedded instance. So yeah, let's actually head over to the demo very soon, where you're going to see the Import-spec in action and the powers of it. Do you want to present the data for the demo, Florent?
Yeah, sure.
Yeah.
So what we're gonna use is a slightly dated model, right? Who goes to a rental, especially to rent DVDs, but yeah, bear with us. Basically, the data set we're gonna show in a minute. So the source data set is a Parquet export of. If you go to the MySQL documentation, you will see this public data set called DVD rental, and basically you have movies, actors playing in movies, movies belonging to some categories, and then customers renting those movies through an indirection called inventory. We'll come back to inventory in a minute, but that's in a nutshell the data set we're gonna try to load and map into a graph with Import-spec. And then the graph model we want looks slightly simpler. So we still have the movies, the actors, the categories, and the customers, but we'll try to get rid of that inventory indirection. Again, I will speak into more details about that. And so, yeah, I will soon start screen sharing, and let's see what I want to talk about. So for that, I think you will need to unshare before I share. Thank you. All right, and hopefully you'll see my screen. So the spec is going to be run in 3 different contexts, but the content is exactly the same. I'm going to also come back to that aspect as well, but at a high level, you really have, at the very least, a version which currently accepts only one value. Sources, in our case, Parquet files, as I will show. Targets, so how you map your source data to the graph, and optionally actions, and I will come back to that. So if we look at sources real quick, I'm not going to explain all of them, but by default, Import-spec does not support any sources. There is a plugin system, and you will have to define your own source configuration and how you deal with that. So in our case, we have a bunch of Parquet files, basically one file per table, because remember it comes from an export. And it's as simpler as having globally unique name, a type. In our case, it's always Parquet, but you could mix types if you wanted to. And then a URI, because that was just the easiest way to describe the source. So remember, sources are named. And then we have targets in 3 families, even though we show only 2 currently. So you have nodes targets, which describe a node that will be created many times into the database. So you specify whether you want to create or merge the node, which label it has, and which source it uses to map data from. So in that case, it's our actor. So it's going to fetch some Parquet data, and then we'll try to map it back to this actor node. Then you've got a bunch of property mapping with optional type that you may or may not want to use. And so we'll get the source field, which comes from the source Parquet file in our case, and how the property is going to be named. And so you will get a bunch of that. And optionally, you can also define some schema elements per target. So like key constraints, type constraints if you want to, unique constraints, etc., etc. So that's, no targets in a nutshell. I'm not going to show all of them. Relationships, are more or less the same. So you still map data from a source. You still give it a globally unique name. You still decide whether you want to create or merge the relationship, but there is an extra level of control, is how you look up the nodes. Do you only match, which means if you don't find the node, you're not going to create a relationship, or do you merge? In our case, we decide to match because we've dealt with the nodes in the other targets. Then you define the type, just as nodes can have several labels, relationship can have one type. And you refer to the start node and end node targets for those, again, using those. And yeah, that's more or less it. And finally, I mentioned this in inventory indirections that we have in user source data, but that we don't want in our graph model. And the problem is really that the rental is split into 2 files. There is this inventory Parquet, where you will get an ID for the inventory entity and a film ID or movie ID. And the rental contains the inventory ID and the customers who rented it. So it's basically split in 2 sources, which is why we have to resort to this optional action I talked about. So targets, as you have understood so far, are mapped from a source. So typically, if you have a large volume of data, you will batch those source data and rerun as many times this mapping logic as there are batches. Actions are slightly different. Actions are not bound to source. They run only once. And by default, Import-spec only supports Cypher actions. You can also define your own, like HTTP or whatever. And in our case, we say when the action is going to run. So it's going to run at the very end of the import. So that is stage end here. So type is Cypher because that's the only built-in supported one by default. And then, I'm not going to go too much into detail, but we find the inventory, resolve the customer, resolve the movie, and then link the customer and movie directly and get rid of the inventory. So that's, since targets are bound to only one sources, that's how we work around this indirection and remove it at the end of the import, basically. And that's the same spec we're going to reuse 3 times with 3 different tools. And so what we tell usually is we have 3 different import-spec backends, because the surface is import-spec, what's running behind is different. So in the case of Neo4j admin, Emre has already shown it, the tests usually look more or less the same. You will have some Neo4j container running locally, because all the examples, which are by the way from the GitHub repo, we're going to link at the end. These ones are running as a test because it's just easier, to cache any issues. So we set up running Neo4j, local Neo4j instance. That's true for all tests. Then what we are going to do is we are going to basically read the spec. So read from somewhere. It could be remote. In that case, it's local. So we're going to get sort of spec content, and then we're going to use this entry point to actually grab this specification object. So now, so far we've taken about YAML. You can also have in JSON. So that's kind of universal. Now we're entering into the JVM world, so Java Virtual Machine, so Java execution and Java library part of Import-spec. And that will give you this Java object. And that reflects more or less what I've shown you with the YAML, with this extra configuration section I've not talked about, free-form configuration, sources, targets, and actions. So that's exactly one-to-one to what I've shown you in YAML. So we read the spec and then we do something with it. We run somehow an import, in that case with Neo4j admin, and then we'll make sure the graph is as we expect in terms of constraints, etc. So I'm not going to run into details too much, but that's expected. And basically the assertions are the same across the whole test because we import the same graph, so we expect the same things. And we specifically, make sure we don't have this inventory node we don't want anymore. We just have customers renting movies directly. So that's customer movies. As you can see, inventory is gone. And just to show you, basically, since you have this property mapping going on in the import-spec sections of node targets and relationship targets, that's what we're using to basically create the invocation command with Neo4j admin database import full. We'll go through all the node targets, specify the node data, so the source file for that node target, potentially create a header, which will define the mapping. We'll do the same for relationships. And if we have schema, so if we have schema sections in any of the targets, we'll also generate the schema file, which is a newer addition to Neo4j admin, and we'll initialize the schema first and then run the import. So that's, Neo4j admin backend example, import-spec backend example. That's just one way to do it. Let's now dive almost straight away, because I forgot one thing, right? I told you, hey, there are no sources by default, so how can we make it work? And so, yeah, the one thing I forgot to mention is we have a plugin system for many things in the Java library side of import-spec. And if we look at, we have a simple plugin system where you have this source provider interface and you can basically define the type you want. Remember this type we've seen in the sources here. We have type parquet, that comes from there. That's this type here. And then you define, okay, here is some raw JSON data. How do you map it to whatever object we want? And so we also define our own object with a name and URI, basically. And this one also has the source interface, which repeats the type, which should be the same between the provider and the source and the name. So that's as simple as that. And once you have that, then you're free to, read data from that custom source object and do something with it. In our case, we just needed URI to be able to resolve the file, fetch the data, and then map it gradually. Or even simpler with Neo4j admin, just give the URI to Neo4j admin, and Neo4j admin will basically deal with it. But that's as simple it is in that case. And that mechanism then requires, it's basically based on the Java plugin system. Again, not going too much into details. You give the source provider as a file name and the implementation or the implementations if you have several sources as this, and then import-spec will automatically discover it for you. And that's true for all the three examples, right? Because again, by default, import-spec does not know any sources. There is just this loose interface. It's up to you to define what you do with that. Then let's switch to a slightly different example, and we'll see how different it is. Not really by the test setup. It's still Neo4j running locally, still reading the import-spec somehow. But as you can see, so far we have this deserializer entry point, but we're not using directly. We're going through import pipeline. And what import pipeline provides on top of the simple import specification object I showed earlier, which is really this one-to-one mapping to the YAML or JSON file, is you will get an ordered sequence of things to import, which is pretty nice, right? Because typically you don't want to process sources at the end, right? You need source data first before you can actually map it to another target. To another relationship, and relationships cannot be processed before their start and end nodes are processed, right? So there is some ordering in place that is actually taken care of for you. So in that case, we just do for each on the pipeline, and it will give us the steps in the right order. And since we're using Apache Beam here, I'm not going to go too much into details, but Beam is able to actually construct a graph of tasks and make sure, and it also has a concept of dependency, so we can, easily say, okay, this node target must wait on this source data fetching task first before it actually proceeds. Same with relationship. You can say, please wait on those start and end nodes first. And so that's why this ordering comes handy, because we are guaranteed that by the time we reach relationship target step, just to follow the Java naming convention here, we know that we've processed those nodes, targets, and sources. So we're all good. And I'm not gonna dive into details, not a Beam talk. So just to show another level of abstraction, a bit over import specification. And finally, this is one of the newer example. I mean, newer as of a few days old. Again, setup is the same. We start a Neo4j server locally. Since we're using Spark in that case, we're also building a Spark session with some Neo4j credentials, so we don't have to repeat all the time. And, we import the same graph, right? And okay, maybe some of you think, hey, you're not even running the test, so let me maybe run this one just to show you that we are not cheating. It's not just dead code that doesn't work. No, it's actually working. And while the test is running, it shouldn't take too long, but still, we're still doing the same. Basically, we're still using the import pipeline, but we'll use it in a slightly different way. You can see this call here with execution plan. An execution plan is also very new. And what execution plan is, it goes one step further than just a simple for each we've seen, the simple iteration we've seen in the Beam example. What execution plan will provide is actually a full graph view of your import. And it will expose things at 3 different levels. One of them is groups. Group is basically a disconnected subgraph. Typically, you will have only one, right? We only have one graph of related things you will import together, but maybe in some cases you will have different disconnected subgraphs, in which case you will have as many groups. And those groups can be processed in parallel. So if you're familiar with the completable future APIs, that's why we are using this all of, which means wait on the completion on all, don't coordinate them more than that. So we just run them all, wait for them to be done, and then we can move on. And within each group, you will actually have something called stages, and those stages are slightly different. So stages are basically tasks to run concurrently. So let's take an example. Let's say you have a relationship target that depends on nodes A and B. And so those nodes have sources as well, relationship have sources. So typically a first stage could be process all the sources. Then the second stage could be process node A and B. And then the last stage could be process relationships that depends on them. So you can already see how sequential it is. That's why we're not using all of here, we're using Zen compose, but that basically means run the first stage, wait for it to complete, then move on to the next stage, and so on and so forth. So that's the only coordination you need to do. You just need to make sure that stages within a group run sequentially, and that's it. And within a stage, that's when you finally get to your targets and whatnot, and that's where so in that case, we are just using data frames. So we create the Spark data frames just in that case to read Parquet files. And then we retrieve them for the nodes, for the corresponding source of the node and relationship. And we then run Spark for this node or for this relationship. And within every stage, it can all run in parallel, and that's all good. And by the way, I think this test has run, it works, it's rerunning the same assertion as before. Yeah, and it runs slightly slower than I expected this time, but maybe that's a demo effect and IntelliJ was a bit stressed, but yeah. That runs basically multiple Spark data frames in parallel through this powerful execution plan abstraction, which is again, really just a graph view of the import. And with that, that's all I wanted to show for today. So remember, one spec, 3 different backends, and 3 different levels of abstraction. But I will let Eric explain it a little better than I did. I think, Emre, you can screen share, since Eric has some screen sharing issue.
Yeah, so I'm just going to recap what we just saw in the demo real quick as a closure, so you really get this ingrained in the retina. So as Florent showed, the sources that we parse is actually loosely defined, or you define it yourself. And in our example, we define the Parquet source with URIs. And this code on screen is basically what you need to get like a simple way of expressing that in our library. And as you also said, with the 3 different demos that you just saw, we had 3 different abstraction levels. So in the first Neo4j admin level, basically all that was needed was parsing the whole import specification and mapping sort of those values into the Neo4j admin tool in the correct way, of course, but sort of one-to-one mapping from spec to parameters. And in the second one, in the Beam example, we go one abstraction level lower because Apache Beam has support for task graphs. And that's exactly what the import pipeline provides, which we can fetch from the import-spec object that you get after you're parsing the spec. And as you saw in the example, or you can check out in GitHub afterwards, is that it was pretty straightforward once you have this pipeline to just map it to Beam straight away. And in the third example is a bit of a flying spaghetti monster, but it works. And in this abstraction, it's just another layer down, which Florian also touched in, is the execution plan. So what you get from us after you declare an import spec is this execution plan, where we separate everything into groups and into stages. And all you, as like the import backend implementer, has to care about in this abstraction level is the order of execution needs to be correct. So if you're doing something like Spark or a custom app, or you get maximum freedom from this essentially, but then you are also responsible for the order. So the groups, which is this whole graph, you could potentially have several different jobs or groups like this and run them in parallel, like independent nodes and relationships. But within each group, you have nodes which depend on each other. And that's why we need to make sure that the first stage you see in the top of the graph, it's sort of hierarchical. And once you've done all the stage 1 nodes, you can go ahead and do the stage 2 nodes, and then all the relationships for those. So this is what you need to worry about if you choose this abstraction level, but you're very free to do what you want with it. So yeah, that concludes our demo. We hope that you folks learned something about this and got your eyes into this amazing library that we have been working on. And yeah, we use this internally, or we connectors team use this library to really make our day easier. We just need to worry about this one import spec for all of the potential imports. And please go and check out the code on GitHub. You have a QR model here, Neo4j import spec. It was posted in the chat by Ali as well. Thank you, Ali. Yeah, and Florian has some recommended talks.
Yeah, so basically just wanted to give a shout out to some of the connectors related talk. So there will be one time is in UTC, so please translate it the best way you can in your own time zone. There will be, it's more drivers adjacent, but it's also quite close to what we're interested in as well in the connectors team. But there will be a talk about how you can use a Java driver to connect over HTTP. So for those of you who know, drivers typically only use the BOL protocol, but now they also support HTTP for the query API you can find in Aura. So that's quite interesting. Again, with this idea of simplifying the life of users. If you want HTTP or BOL, then you don't have to switch. There is another talk, so that slightly will have you will have to choose. So don't make Emre sad, because Emre is going to speak about Fabric with Stuart, our PM. At the same time as Drew, who will be speaking with June from the data importer team about this Aura import service we briefly mentioned. And finally, there is a very cool talk in the middle of the day, in UTC-wise at least, which is about Flink. So using JDBC, Flink, and running some imports with that to Neo4j. So that's pretty experimental and new and cool. So yeah, don't miss that. And I think that leaves us some time, maybe like 10 seconds for questions, but I think Ali did indeed a great job at answering them in chat. So yeah, thank you very much, everyone.